This is AP Calculus, AB. Note section 7.3, solving differential equations. These are examples of separable differential equations, which means we can successfully separate the variables. There's some problems where you cannot successfully do that. Directions. Given below are differential equations with given initial conditions. Find the particular solution for each differential equation that satisfies the given initial condition. In order to do this, you have to first separate your variables. In other words, you want all of your y's on one side and all your x's on the other. If I take this equation that I have right here, and I multiply both sides by dx, I would get dy equals 6x squared plus 6x plus 2 dx. If I then put an integral sign in front of both of these, I can then integrate these. Remember, when you integrate, you must have an integral sign and you have to have a dy or a dx. Like essentially it's an integral sandwich. On the left, there's nothing between the integral sign and the dy. That means there's a 1 there. The antiderivative of 1 is y. On the right, integrating 6x squared plus 6x plus 2 is 2x cubed plus 3x squared plus 2x plus your arbitrary constant. Now, a couple of things. Technically, there's an arbitrary constant on both sides. Let's say k is an arbitrary constant, and so is c. When you move the k to this side, you're going to get a different arbitrary constant. The point is, if you take two numbers that you don't know and you add them together, you're just going to get a third number you don't know. Too long didn't read. When you integrate a separation of variables problem like this, a differential equation, just put the plus c on the side that has the x's. Just quick review how to integrate. You add 1 to the exponent, which is a 3, multiplied by its reciprocal 1/3. 6 times a third is 2. This next one, the exponent is a 1. Add 1 to it, you get 2. Multiplied by the reciprocal, half of 6 is 3. The next one is a constant 2. Its antiderivative is a linear equation, 2x, and then add in your arbitrary constant. This represents the general solution. This represents many possible solutions to the original differential equation. Depends on what c is. We were given an initial condition. That initial condition is that f of -1 is 2. If we plug the 2 in for y and the -1 in for x, we can evaluate and figure out what c is. Because if we know what c is, we're going to have a particular solution. -1 cubed is -1 times 2 is -2. -1 squared is positive times 3 is 3. -1 times 2 is -2. This ends up giving us 2 is -1 plus c, so 3 is c. So our particular solution, as the directions calls it, is going to be f of x equals 2x cubed plus 3x squared plus 2x plus 3. To get that answer, I'm combining what I had y equal to, and then I'm substituting in what I know is c. Let's check out another. Number 2, we want to separate the variables. We want our x's on one side and our y's on the other. So I'm going to multiply both sides by dx, like we did last time. I'm going to also simplify this right side a bit. This is a fraction, but it doesn't have to be a fraction. I could rewrite this. Let me move this over here a little bit. I could rewrite the numerator, well, leave the numerator the same, I should say. I could rewrite the denominator as 2 to the x, 2 times x to the 1/2 And then if I want to move this to the top of the fraction, first of all, the 2 means dividing by 2, which is the same as 1/2. Then I could make this x to the negative 1/2 to reciprocate the base. Then if I distribute in the parentheses here, I'm going to get 1/2 x to the negative 1/2 plus 6x. When you multiply with the same base, you add the exponents. 3/2 plus a negative 1/2 is 2/2, which is 1. So that's convenient. And this is with respect to x. I'm now going to integrate both sides. The left side, conveniently, again, if you integrate 1 with respect to y, you're going to get y, plus an arbitrary constant, which we're not going to write. We're just going to write it on the right side. On the right, if you add 1 to this exponent, it's going to be 1/2. Multiplied by the reciprocal. The reciprocal of 1/2 is 2. 2 times 1/2 is 1. I'm just going to put the 1 there for emphasis. Plus, add 1 to the exponent here. You're going to get to the second. Multiplied by the reciprocal. 1/2 times 6 is 3. And then you throw in your arbitrary constant. This is the general solution. To find a particular solution, you take the ordered pair that you were given. I'm going to put a 2 in for y and a 0 in for x. This is going to give us that c is 2. So you get your general solution, figure out what c is, and you get your particular solution. Our particular solution is going to be f of x equals square root of x plus 3x squared plus the arbitrary constant of 2. This is particular solution, which is all the direction asked for. It doesn't ask for the general solution. I'm just pointing it out because that's going to be relevant in later sections. Number 3, this one's a little different. We got y's on both sides, whereas before we had x's and dx's on both sides, and we just had a dy on the left. So to move this over here, I'm going to multiply both sides by 2y. To move this over here, I'm going to multiply both sides by dx. That's going to give us 2y dy equals x squared plus 2x dx. Now that our variables are separated, x is on one side, y is on the other, we're going to integrate both sides. The left, if you integrate 2y, add 1 to the exponent, you get y squared. Multiply by the reciprocal of 2, that's a half. 2 times a half is 1. There's an arbitrary constant on the left. But there's 1 on both sides. We're just going to write it on the right each time. On the right, integrating x squared is 1/3 x cubed. Integrating 2x is x squared. Throw in your arbitrary constant. Now this is not actually a general solution. To get y by itself, you get a general solution. But instead of doing that, I suggest once you've integrated, figure out what c is. To figure out what c is, we're going to put 2 in for y, and we're going to put 0 in for x. That's going to give us 4 is c. This problem's a little bit different because once we integrated, we didn't have y by itself right away. So now we got y squared equals 1/3 x cubed plus x squared plus 4. This is not a particular solution yet because we have to get y by itself. To get y by itself, you square root both sides. You're going to get y is plus or minus the square root of 1/3 x cubed plus x squared plus 4. This is 2 different answers. This can't be a particular solution because a particular solution wouldn't have 2 versions. There's a positive version and a negative version. What you want to ask yourself is, which equation contains the point that we were given, 0, 2? And that's easier to answer than you would think in this particular problem. This y value is 2. For y to be a positive 2, this has to be the positive version. Y couldn't be equal to a negative thing. If at 0, 2, it has to be positive. So our particular solution for this, f of x equals the positive version of the square root of the sum of 1/3 x cubed plus x squared plus 4. This is our particular solution. Let's check out number 4. Hopefully this gets a little harder. It's more fun when they get harder. We want to separate our variables so we have our y's on the left and our x's on the right. I mean, it could be the other way around, whatever is most convenient. I'm going to multiply both sides by y and multiply both sides by x. That was simple. Then I'm going to integrate both sides. Remember, to integrate, you have to have an integral sign and a d variable as well. And that variable has to be the same as this variable. Same thing on this side, integration sign, we got a dx, and the variable in here is an x. Just a little reminder. Integrating y is going to be 1/2 y squared. Integrating x plus 2 is going to be 1/2 x squared plus 2x plus c. Y squared by itself on this, multiply each side by 2, each term. And we end up with y squared is x squared plus 4x plus c. If we then try to find the particular solution using the ordered pair that we were given, f of positive 1 equals -3. Put a -3 in for y, put a 1 in for x, and we're going to get 9 equals 1 plus 4. So this is a 5, subtract 5 from both sides, we're going to get c is 4. Once c is 4, we can take this fellow here and square root both sides. We're going to get plus or minus the square root of x squared plus 4x plus 4. Now that's two different answers once again. It's a positive and a negative version. So the question you got to ask yourself, which equation contains 1, -3? Well, this y is negative. This y, our choice is a positive or negative. We're going to choose the negative one because that's negative. So f of x equals negative square root of x squared plus 4x plus 4. This is our particular solution. On the flip side, this one is just wet and wild. It's like a swimming pool. I'm going to multiply both sides by dx. And then we got to divide both sides by y minus 2. We want our separation of variables. If we then integrate both sides, right side's simple. Integrating x to the 4th is 1/5 x to the 5th. Add 1 to the exponent, multiply by the reciprocal of the exponent. Left side's not so simple. We cannot integrate that directly. We're going to use a u substitution. We're going to set u equal to the denominator. It makes du over dy 1, which makes du equal to dy. So using substitution over here, we're going to be integrating 1 over u, replacing dy with du. Now the left side is easy to integrate. Integrating 1 over u is natural log of the absolute value of u, plus an arbitrary constant. We already have that on the right side of the equation. U isn't actually u. U is y plus y minus 2. So this is natural log of the absolute value of y minus 2 equals 1/5 x to the 5th plus c. Now at this point, let's figure out what c is. We had an ordered pair here of 0, 0. So it's going to be natural log of the absolute value of 0 minus 2 equals 1/5 0 to the 5th plus c. Natural log of the absolute value of 0 minus 2, well, that's going to be natural log of negative 2, which is natural log of 2. And this right side is just going to be c. So we know what c is. It's natural log of 2. Fun has not stopped yet. So now we got to figure out what the particular solution is now that we know what c is. So we got natural log of the absolute value of y minus 2 equals 1/5 x to the 5th plus natural log of 2. We need to try to solve for y. This is currently in log form. This is currently written as log base e of the absolute value of y minus 2 equals. Natural log means it has a base of e. To put it in exponential form, you take the base, e, raised to the exponent, 1/5 x to the 5th plus natural log of 2, and you set it equal to the argument, the absolute value of y minus 2. Now at this point, there are two solutions. Well, before we do that, this here can be simplified quite a bit. E to the 1/5 x to the 5th times e to the natural log of 2 is the same thing that you see up here. Now, why is that? Because if you multiply with the same base, e, you add the exponents. So it stands to reason that if your exponent has addition in it, you could separate it and make it multiplication with the same base. So what does that do for us? Well, e to the natural log of 2 is just 2. It's one of our identities that we had in pre-calculus. If you have any number raised to a logarithm that has the same base as that any number, then this whole thing just becomes the argument. So in our specific case, we have e raised to the log base e of 2, because remember, natural log is the same as log base e. And the right side is the absolute value of the difference of y and 2. So since this is an absolute value, it means there's two versions of the answer. Absolute value means what is inside this could be positive or it could be negative. And then once you take the absolute value, it becomes positive. That's why the left side's positive. So there's two versions of this. Either we have the negative version, which is y minus 2 equals negative 2e to the 1/5 x to the 5th. Or we get the positive version, y minus 2 is positive 2e to the 1/5 x to the 5th. If we solve each of these little fellas, I know what you're thinking. Why didn't I just take an easy math class? Because it's not very fun. That's why. So then the question we got to ask ourselves yet again, which equation contains the ordered pair that we were given, 0, 0? Well, let's try to figure this out. If we put it into this first one, we end up with 0 is negative 2. You know what? I apologize. I forgot to put the plus 2 here. Let me highlight that. We had a minus 2 here. We add 2 to both sides. We get a plus 2 over here. 1,000 pardons. 1/5 times 0 to the 5th is going to be 0. E to the 0 is 1. 2 minus 2 is 0. 0 equals 0. That checks out. Let's check this other one. 0 equals 2e to the 1/5 times 0 to the 5th plus 2. That's going to be 2 times e to the 0 plus 2. It's going to be 2 plus 2, which is 4, 0 does not equal 4. So what is our particular solution after all that? Well, it's f of x equals negative 2 e to the 1/5 x to the 5th plus 2. Lovely. Let's check out this next little fella. Separation of variables. I need to first of all, get rid of my fractions. I'm going to multiply both sides by x squared and both sides by dx. Now, if you're not careful, you might think that your variables are separated, but they're not. The left side has x's and y's, the right side has x's and y's. Then I'm going to divide both sides by x squared. That's going to give me 1 over x squared dx. I'm going to divide both sides by y minus 1. It's going to give me 1 over y minus 1 dy. Now my variables are separated. If I then try to integrate this, well, first of all, on the right, I'd rather be integrating x to the negative 2. Because that's easily done without substitution. Which is going to be, if I add 1 to the exponent, it's negative 1. Multiplied by the reciprocal of negative 1 is negative 1. So that's going to make the right side negative 1 over x plus c. The left side, I'm going to have to set u equal to y minus 1 because I cannot integrate this directly, which is going to make du over dy 1, which makes du equal to dy. So integrating this, I'm going to have 1 over u du. This is natural log of the absolute value of u, and u is y minus 1. Hopefully you can see where this is going. This is going in a very similar direction as the last problem, which is good because you likely need practice on this. Ordered pair that we have for this is 2, 0. So I'm going to have natural log of 0 minus 1 equals negative 1 over 2 plus c. That's natural log of the absolute value of negative 1 equals negative half plus c. It's natural log of the absolute value, that's natural log of 1 equals negative half plus c. Quick reminder, natural log of 1 means log base e to the 1. And what does this mean? It means e to what exponent is 1? And the answer is 0. So this is 0 is negative 1/2 plus c, which means that c is 1/2. If c is a half, then we can say that our equation, natural log of the absolute value of the difference of y and 1 equals negative 1 over x plus 1/2. To get our particular solution, we're going to have to solve for y, which is going to require using logarithms and exponents. We already have logarithms. So let's change to exponential form. This is currently in log form. We're going to change to exponential form. So our base is e. Our exponent is negative 1 over x plus 1/2. It's going to equal the argument of the absolute value of y minus 1. Then I got to break this apart into two different equations. We got the y minus 1 that's equal to a negative version of this. And we have the y minus 1 that's equal to the positive version of this. I don't need to put the plus, but it's just there for emphasis. Solving this one, we're going to get 1 minus e to the negative 1 over x plus 1/2. And over here, we're going to get 1 plus e to the negative 1 over x plus 1/2. So the question is, which one contains 2, 0? Well, let's try to figure this out. Put it on the left one, we would have 2 equals 1 minus e to the negative 1 over 0. Oh, we got a little problem here, don't we? Problem is I don't know how to put variables in correctly. Putting a 0 in for y, putting a 2 in for x, it's going to give us 0 equals 1 minus e to the 0. E to the 0 is 1. 1 minus 1 is 0. It sure looks like this one's going to work. Let's try this other one just to make sure. 0 equals 1 plus e to the negative 1 over 2 plus a half. That's going to get 0 equals 2, which is not true. Therefore, f of x equals 1 minus e to the negative 1 over x plus a half. That concludes the notes. Thank you very much.